Here we go. We have a question, count symmetric integers. You are given two integers, high and low. An integer x of 2 cross n digits is symmetric if the sum of first n digits of x is equal to summation of the last n digits of x. Number with an odd numbers of digits are never symmetric. We need to return the number of symmetric values. So we have 1 to 100, 1 to 100, and in this range we need to figure out what are the symmetric values. So it means the first, if we divide the value into half, so the first portion and the second portion, the summation should be same. So between this, we cannot create between 1 to 9 since there is odd length, but from this to this we can create some values. Then from 100 to 909 we cannot create, so this is odd length. We have to consider only for even length. And let's figure out for constraint. Yes, the constraint is 10 to the power 4, so 1000 to 10 raised to power 4, yeah, till this, till 999. So this is even length, this is 2 length, this is 4 length. So we have between this and this, right? So between this and this, so let's first figure out for 2 length. So for between 2 we have 11, 22, 33 and 99, right? So the value should be divisible by 11. Any value between this range should be divisible by 11. So if this is divisible, we just calculate it. Otherwise we have this thing, and in this what I will do, so this case is handled already, we have to handle for this case. So for this case, what we have, this is symmetric, this is symmetric, this is symmetric, this is symmetric. So all this value and etc are symmetric. So if any 4-digit value is there, we have to first divide into two portions. This is my left portion, this is my right portion. How do we divide? So how do we get these two values? So if I have given this value, how do we get the first two values and the last two values? So what I will do, so let me create let me get a value, this value, right? How do we get 2, 5, 4 and 3? So 2, 5, 4, 3, if I do like this, I will get 2, 2, 5, 4, 3. Then I will do this, I will get 5, 4, 3. Then I will get 100, I will get 5. So these two values I can get. Then between this, if I do 100, I will get 43. If I divide it with 10, I got 4. 2, 5, 4, 3. If I get the remainder with this, I will get 3. Right? As simple as that. This question is pretty simple. So let's just iterate it and find our answer. Low till high. If my value is greater than equal to 11 and less than equal to 99, if I is divisible by 10, okay, let's write it, I modular 11 is 0, it means divisible by 11. So just increment our answer. L if this value is 4 digit, so this is 4 digit, then I will get first, second, third and fourth digit. So let me write it like this: d1 I divide 1000. d2, how do we get d2? d2, first we apply modulus I modulus 1000. This will give me 3 digits, which is 543. Then if I divide with 3 digits, I will get my d2. How do we get d3? If I do the remainder with 100, I remainder 100, this will give me two digits, which is 43. Then if I divide with 100, I will get the last second. For the last value, if I do the remainder with 10, it will just give me value. If d1 plus d2 is equal to d3 plus d4, then answer will increment. Just return the answer. Let's run this. And we have an issue here, and symbol, and I hope this will work. We have an error here. We have wrong answer. We are getting wrong answer. So we have made a mistake, which is first we have to apply modulus with 1000. Yes. Then we have to apply the division with 100. So then we get 5. Here we have to first apply modulus with 100, then the divide operation with 10. And let's run this. And in between, let's talk about time and space complexity. So our time complexity is order of high minus low, and my space complexity is constant. Thank you all for watching.